We're on the last section of chapter 3, which has us graph linear functions. First, we're going to find an input or an x value of a function. We're going to graph and compare functions then, and we'll do a real-world problem. Just a reminder that functions are very much like equations, except functions have only certain inputs that then have outputs then. So that's the difference between functions and equations, and we'll notice that as we go along. First, we need to find the input or the x value of a function. So here's given us the function. For the function f of x equals 2x minus 10. Find the values of x so that f of x equals 6. So find the input of x so that the output is 6, is another way of saying that. So we have f of x equals 2x minus 10. And now we could say 6 is the output here, equals 2x minus 10. And then this turns into a two-step equation. So we would add 10 to both sides. That would give us 16 equals 2x, divides both sides by 2, and then we would see that 8 equals x. So if you have an input of 8, that'll give you an output of 6 in this equation. 16 minus 10 is 6. Here we need to graph the functions here, and then compare it with the graph f of x equals x. So when the input matches the output, this is what it looks like. 1 comes out as 1, 2 comes out as 2, 3 comes out as 3, 4 comes out as 4, negative 1, negative 1, negative 2, negative 2. Let's see how these ones compare when they're a little bit different. Here we have g of x. So g of x, the output equals the input of x plus 3. So let's graph this out in, let's do this in red. So we have 0. When the input is 0, the output would be positive 3. When the input is 1, you would do 1 plus 3 would be 4. Input of 2 would give you an output of 5. 3 would give you an output of 6. Let's do negative 1. Negative 1 would give you an output of 2. Negative 2 would be positive 1. Negative 3 would be 0. And I think by now we can draw that line. So if we're going to compare it to this graph f of x, we see that they're parallel lines, and that's because they have the same slope. Look, the slope is 1 for this, and the slope is 1 for this as well. The only difference then would be the y-intercept. See how this one's 3 above it? So that's the only difference. They actually could go right on top of each other if the y-intercept was the same. Here we have h of x now, and that's 2x. So let's do this in blue. Okay, so h of x, the output is always 2 times the input. So if I have an input of 0, it's going to be 0. If I have an input of 1, it's going to be 2. Input of 2 is going to be 4. Input of 3 is going to be 6. Input of 4 is going to be 8, which is a little off here. Then I'd have negative 1 would be negative 2. Now let's graph that one out. We said that they both cross through the origin. That's because there's nothing being added to this x and there's nothing being added subtracting this x. So that means they're going to go through that same origin point. But we see that the slope is twice as much as this. See, it's twice as steep. That's because this is just 1 times x, and then this is 2 times x. So this would make sense that this slope would be twice as steep. Now let's look at a real-world problem. Here we have a cable company charges new customers $40 for installation and then $60 per month for its service. So the cost to the customer is given by this function. The output, or how much you pay, equals 60 times the x, which is the months, plus $40 for that installation. So x is the number of months of the service. To attract new customers, however, here, the cable company reduces the installation fee to $5. So this function for the cost of with this reduced installation fee is the output equals 60 times the x, or month, plus only 5 now instead of 40. So graph both functions, and then we're going to say how is the graph of g related to the graph of f. So f is the old deal where you paid $40 for your installation, and g is your new deal where you pay only 5. So let's graph these out. So at 0 months, we're only going to be paying that installation fee, which would just be 0 times 60, which is 0 plus 40 is 40. So right below that 50. We're going to do that in blue. I'm going to do the other one in red, I guess. So we'll do 0 times 60 plus 5. That's 5. So really close to the bottom here. And here we'll plug in the months at a time here. We have 1 month. So 1 times 60 is 60 plus 40 is 100. So we'll do 1 month at 100. The red one we would do 60 times 1 is 60 plus 5 is 65. F of x, we have 60 times 2 is 120 plus 40 is 160. So that would be right here. For the other one, we would have 60 times 2 is 120 plus 5 is 125. It's right around here. Next one would be 3 times 60 would be 180 plus 40 is 220. It's right here about. For g of x, 60 times 3 is 180 plus 5 is 185. That'd go right around here. We'll do one more month. F of x, 6 times 4 is 240 plus 40 is 280. It's right around here. And then we'd have 60 times 4, which is 240, plus 5 is 245. So right below the 250 mark. Then we can graph these out with the lines. We'll do a blue line first, starting from the origin, plotting these out, and then we'll do the red line, start at the origin, and plot them out. And we notice that these lines, they should be, I didn't do this very well, but they should be parallel because you're paying that same rate for every month. We see the only difference here is that you start at a higher amount and that stays at that higher amount. It doesn't get any more, but it stays at that. It's going to be $35 more than the other ones here. So that's what you would say. It stays no matter how many months you have the deal. And that's an important concept to learn here because we're paying, no matter what, you're paying that $60 per month. So that's going to be the same. The only difference is at the beginning you only pay 5 here where you paid 40 with the original deal. And that's where you're going to see the difference on the graph.